Math 3, Unit 4, Section 6. Today we're talking about graphing rational functions. So this first function right here, okay, y equals 1 over x, that's kind of our parent graph, okay? This is what your parent graph looks like. If we're talking about the functions, it starts out as y equals 1 over, and I'm going to write it like this, x plus 0 plus 0. Okay? And so there is an asymptote. If we set x plus 0 equal to 0, we would end up getting the equation x equals 0. Okay? And x equals 0 is this vertical line. And I'm going to write that as VA for vertical asymptote. Okay? Over here, this adding 0 at the right, we would set that as y equals 0. And whatever value that is, you would put for your y. Okay? And so there is a horizontal asymptote at y equals 0. So remember, this is going through the value y equals 0. So there are two asymptotes there. Remember that when you're adding something at the end, it is shifting it or translating it which direction? Up. So the adding value at the end is dealing here with your y, so it's going to move it up, or if it's subtracting, it's going to move it down. Okay? When it has x plus c, that means it's going to go which way?
Left.
Very good. And minus c would go
Right.
correct. Okay? The negative in front like this, it's going to reflect it about the,
Y. X, sorry.
it's okay, x-axis, because it's the opposite y value, which is reflecting across the x. And on this one, it's the opposite x value, which means it'll reflect across the y-axis. Okay, again, your horizontal asymptotes are y equals a value, and your vertical asymptotes are x equals a value. The last thing I want to remind you of, and we talked about it before we started our recording, but Desmos.com is a great way to check answers and to plug in your graphs to see if you did them correctly, or plug in your equation and check to see if you graphed it correctly. All right, so we're going to start here with our first example. Okay, so right here, x minus 2, if we set that equal to 0, what will that be?
X plus 2, or x equals 2.
X equals 2 is correct. So if we go to x equals 2, we will have an asymptote right here at x equals 2. Okay, what about your other asymptote? I'm going to give you just about 10 seconds to see if you can do that one. Okay, if you said 1, you are correct. I'm just giving a minute for everyone to give it a try. So there should be another asymptote there at y equals 1. Okay, the next thing, in order to make this graph as accurate as we can, you will always, once you have your asymptotes, you need to find your Y-intercept and your X-intercept. Okay? And then you'll be able to do both of your curves. Who remembers how to find your Y-intercept? I hear it, yeah. Plug in 0 for X and solve for Y. So if I do that, if I plug in 0 for y, even though this says f of x, that's the same as there being a y there. So we would write this as y equals 1 over 0 minus 2 plus 1. I put in 0 for x, and now we're going to solve for y. So what is 0 minus 2? -2. Good. So if I'm simplifying this, we now have 1 over -2 plus 1. Most of you should be able to do that in your head and get the answer. But mathematically, when you're adding and subtracting fractions, we need to have what? Common denominator. So that means we want this 1 to end up having a denominator of just 2 is fine. And this is really 1 over 1. So in order to get 2, we'd have to go 1 times 2, which is 2. And on the top, 1 times 2, which is 2. So do we all agree that 2 over 2 would reduce to be 1?
Yes.
Yes. So now we have this negative. Remember, the negative can go with the top or the bottom. So we want the negative with the top. So 2 minus 1 equals
1.
Okay, I was worried for a second. So 1 over 2 is the correct answer, 1/2. So 0 for x, 1/2 for y. All I'm doing is simplifying. We're just adding and subtracting fractions. Okay? So if we go and plot this on the graph, 0, 1/2, 0 on the x, 1/2 on the y, there is a point right there. So we have our y-intercept. Now we need to find our x-intercept. How do I find the x-intercept? Plug in 0 for y and solve for x. Okay, so if we look up here, here's my equation. I'm plugging in 0 for y. I would write that as 0 equals 1 over x minus 2 plus 1. Does this look familiar to everything we've been doing in this unit? It should. Okay, so we want to eliminate that x minus 2 from the denominator. How would I do that?
LCD.
Very good. What would be my LCD for this problem?
2.
Very good, x minus 2. And again, I'd probably put that in parentheses there. Also, what are my extraneous solutions?
2.
X cannot equal 2. Now, if you look at the graph right now, do you see this line here at x equals 2?
Yeah.
It's an asymptote. Doesn't it make sense that x cannot equal that value? It gets really close to asymptotes, but it can never actually equal it. Okay? Make sense? All right. So, what am I going to do now? Very good. Multiply every single term by my LCD. We are multiplying x minus 2 to every single term, just like we did previously in section 4, section 5, now section 6. Okay, what is 0 times anything? 0. Very good. What happens here? X minus 2's cancel out, and I'm left with 1. And I'm going to go ahead and write this out, but you could distribute if you want to. This is 1 times x minus 2. Okay, so now I have 0 equals 1 plus 1 times x is x, and 1 times negative 2 is negative 2. We are just going to simplify this equation. Okay, so I still have 0 equals, what is 1 and negative 2 when I combine them? Negative 1 plus x, and then what will I do? Add 1 to both sides. And so I end up getting 1 equals x. So on the x-axis, where am I going to go? 1, 0. So I'm going to go right 1, up 0. And then we can see that our curve is going to be right here. Now, based on us talking in Desmos and looking at our parent function, okay, back here, you always have 2 curves, and they're always diagonal from each other. So if I have a curve, and this would be quadrant 3, the other curve is going to be in quadrant 1 up here. Okay. Questions up to this point? Okay. Now we're going to go and answer all these questions. Okay? Domain. Domain is always dealing with our x value. Very good. So, If you need a new note card, you can come and grab one or get one from the drawer later or whatever you want. But remember the domain, we start at the left. Since we have an arrow there, we know it starts at negative infinity. Okay, and it goes along. And when you get to an asymptote there, you have to stop. So that means we're stopping at 2. So negative infinity to 2. And then it starts right back up again at the 2. And it goes all the way to that arrow, which is positive infinity. We do the same thing with the range, right, Ethan? Okay? And so the range is dealing with our y values. And so if we go down here, it's at what value? Negative infinity. As we go up, we have to stop at our asymptote, which is at which value? 1. And then it starts right back up again at 1 and goes to positive infinity. Okay, so again, make sure you remember that domain is dealing with your x's, range is dealing with your y's. Okay, next, state the equation of vertical asymptotes. Vertical, remember, is up and down. There is a vertical asymptote here at what? X equals 2. There is a horizontal asymptote at y equals 1. Okay, next it asks us to state the intervals on which the graph is increasing. Now remember that when you're reading increasing or decreasing, you are always reading your graph from left to right. Okay, now as you're going from left to right here, what's it doing? Going down. It's decreasing. What's happening here? Decreasing. So what's the intervals? None. There is no increasing. Everything is decreasing. And just so you know, with these graphs, they're either both going to be increasing or both decreasing. Okay? Next, state the intervals on the graph of which it's greater than 0. So if I go here, I'm going to mark at the line of 0. Do you see how it's greater than 0 here and here? So we need to write that. It starts at negative infinity. It's greater than 0 at negative infinity all the way until you hit this point. Where is that point at? 1. Now, we just use parentheses because it's saying where is it greater than 0? When it's at 0, it equals 0. It's not greater than 0. So you're only going to be using parentheses on these. Okay? And then it's below 0 here. It's less than 0 here. But it's still greater than 0, and it starts at your asymptote and goes to positive infinity. So where is my asymptote at? 2 all the way till positive infinity. Do we have any questions there? All right, let's move on to the next one. Okay, so here you'll notice that there is a negative up here, which means there is going to be some reflection. Okay, but because we are finding our Y-intercept and X-intercept, that will help us with where the graph is. So you don't really have to worry about that reflection right now. Okay, what we do need to do though is mark our asymptotes. So where is my asymptote going to be for the x plus 1? X will equal at negative 1. So we're going to go to x equals negative 1 and mark our asymptote. Okay, this minus 2 is going to give me the asymptote for what? Y equals negative 2. Good. How do we find our Y-intercept? Good, 0 for x. So we use our equation. We will write this as y equals negative 1 over 0 plus 1 minus 2. 0 plus 1 is what? 1. And so negative 1 over 1 will actually be what? Negative 1, right? And we have negative 1 minus 2, which equals negative 3. So my ordered pair, the x is 0. We plugged in 0 for x, and we found negative 3 for y. So I'm going to go mark that. 0, negative 3. There is a point right there. Because of my asymptotes, I can go ahead and draw that curve because there's no way this can hit the x-axis. So there's my curve. Where's my other curve going to be?
Quadrant 2.
Very good. Over here in quadrant 2. Okay. How do we find our x-intercept? Because we're going to have to find our x-intercept, right? Okay. Plug in 0 for y and solve for x. So 0 equals negative 1 over x plus 1 minus 2. In order to solve this, what would I need to do? Very good. LCD. And what is my LCD for this problem going to be? X plus 1 is correct. And my extraneous solutions are x cannot equal negative 1. And we can see why, correct? There's an asymptote. There's no way x can equal a value on that asymptote. Okay, so now what do I do? Multiply every single term by my LCD. Okay, what is 0 times x plus 1? 0. Equals, here the x plus 1's cancel, but I'm left with negative 1. And then I have minus 2 times x plus 1. Next, I'm going to distribute the negative 2 through. So I still have 0 equals negative 1, and then negative 2 times x is negative 2x. Negative 2 times 1 is? Next, we'll combine like terms. Do you guys see how we have our like terms of negative 1 and negative 2? And together those make 0 equals negative 3 minus 2x. What will I do to solve for x? Add 3 to both sides. That's what I thought. 3 equals negative 2x. And then the last step now would be to divide by negative 2. Now, for me, you could write this as 3 over negative 2, but when you're graphing, it's better to change this into a mixed number. So what is that as a mixed number?
1.5.
Yeah, negative 1.5 or negative 1.5. So as an ordered pair, this is negative 1.5, comma, 0. That's my x value and then my y. Where is negative 1.5? In between negative 1 and 2. So there's my x-intercept, which makes sense. It's diagonal, right? So it works out, and we can go ahead and draw the curve. And remember, your curve gets close to your asymptotes, but it never actually can touch the asymptotes. Okay, with this information now, we need to state our domain. So going from left to right, my domain starts at negative infinity. It has to stop at asymptote, which is negative 1. It starts back up at negative 1 and goes to positive infinity. Our range is where we're going up and down. Okay, so starting down, I'm starting at negative infinity. As I travel going up, I have to stop at negative 2. I start back up again at negative 2, and I go all the way to very good. Okay, vertical asymptotes. What values do I have for vertical asymptotes? X equals negative 1. Very good. Horizontal asymptotes are at y equals negative 2. Okay, if we're reading this, it says, where is it increasing? Is this increasing? Yes, so that means the whole thing is increasing. If it is true, if it's increasing what it asks for, it's always just restating your domain. It's increasing on the whole graph. All your answers come from the domain unless it asks for the range, okay? And so this answer is just negative infinity to negative 1 with the union of negative 1 to infinity. It's increasing from here to here, and then it's increasing from here to here, the whole graph. Okay, state the intervals on which the graph is less than 0. So if I draw this, here is where my 0 line is. There is graphs that are less than 0, okay? It's less than 0 here. It starts at negative infinity, and it hits 0 at what point? What was that point? Negative 1.5, okay? And then it's less than 0. It starts up at my asymptote, which is at negative 1, and goes to infinity. All the rest of the graph is less than 0, which I find like the card is helpful, or if you use your hand to like block off what is less than 0. Okay, state the equations for horizontal and vertical asymptotes. This should be pretty easy. Every single problem has horizontal and vertical asymptotes. Okay, what is my vertical asymptote? X equals negative 5. Make sure you write it as an equation. My horizontal asymptote, if there's nothing added here, that means it's really adding 0. So that is at y equals 0. Over here, what is my vertical asymptote?
7.
X equals 7, because we set that equal to 0. And my horizontal asymptote is at y equals 4. Any questions there? Okay, turning to the next page. Okay. Oh, yes? Yes. No. So the only ones you said equal to 0 are the ones that you would put in parentheses like that. And this one is the one at the end, and that one doesn't change. Okay. All right, so real quick, because I know we're running out of time, they asked you to solve the equation f of x equals g of x. Here is f of x. Pay attention to the whole thing. Here is g of x. So if I write that, I have 2 over x plus 1 minus 3 equals negative 2. Now, it's best for this to be set equal, or what would I do to solve this? When you're graphing, it's best for it to be set equal to 0. So let's go ahead and do that first here just to see, because we're going to end up graphing it, okay? So I'm going to add 2 to both sides here for a minute. And so I would have 2 over x plus 1. What's negative 3 plus 2? Minus 1. So when you're graphing, this is what you would graph. Y equals 2 over x plus 1 minus 1. Okay? But we're solving this. Okay? What will I do to solve this? What would be my LCD? X plus 1. Okay? And if the bell rings, I'm going to go ahead and keep finishing this to post it online, and you can go finish it later. So just so you know. Extraneous solutions are x equals what? Okay, so I multiply every term by x plus 1. We still have a couple minutes, though. You guys are okay.
We're okay.
Multiply every term by x plus 1. What happens here? Cancels out. We get 2. Are you guys okay with me distributing this right here?
Yeah.
Negative 1 times x is? Negative x. Negative 1 times 1 is? Equals. And 0 times anything is? 0. Combine our like terms. We have negative x. And my like terms would be 2 and negative 1, which ends up making a 1. And then it's up to you on what you do. I would go ahead and just add x to both sides to make x positive, and I get 1 equals x. So my solution, the answer to this, is that x equals 1. Now, when you graph it, you have to use this to graph it, okay, where you're setting it equal to 0. Where is my first asymptote? X equals what? X equals negative 1. And then my horizontal asymptote is at y equals negative 1. Okay, when you solve that, you got the x value, the x-intercept at 1. Now, because they didn't ask me to find the y-intercept, I don't have to make it accurate, although you could. But because this x-intercept is right here, I know that this curve is here, and the other curve is down here, diagonal. Okay, the relationship between A and B is that part A is actually an ordered pair, which is at 1, 0, okay, ordered pair, where part B is just the X value. And you could write that in better sentences than me, but that is the difference. Any questions?